So looking at 9.6 and in 9.5 on Tuesday, you did sine and cosine, right? And SOHCAHTOA, so we know, what is what between sine, cosine, tangent. We're going to take that idea and we're going to apply it to a new situation today. We're going to take those ratios and we're going to apply it to something else. Remember, the calculator knows those ratios. If you type into your calculator the sine of 25, it's going to give you that ratio. That it's always going to be the opposite over hypotenuse. It's always going to be that ratio. What we're going to do today is use that calculator to go backwards on it. We're going to use that calculator. We're going to say, all right, this is the ratio we have. What's the angle measure? Okay. So we're solving for angles today. That's what we're going to do. And if you look on your calculator, get your calculator out. If you look right above sine, cosine, tangent, right, the second functions of those buttons, it has the -1 on it. Those are called the inverse. So when we see that with the sign with the -1, we call that inverse sine. Okay, that's inverse sine. And then, of course, inverse cosine, inverse tangent. That's what we're going to use to be able to find the angle measures in triangles, in right triangles specifically.
Well, and all this stuff will only work on right triangles.
Yes. We will eventually look at triangles that are not right triangles, but the meaning gets a little mucky at that point. Okay, so for right now, the way we understand sine, cosine, tangent, only right triangles. All right. So let's say that we've got our triangle. We're going to try to solve angle A. And let's say it's we got a 3 and a 5 there. So we're going to try to solve for angle A. We're going to find out what angle A is, how many degrees. We got to first figure out which one we're going to use, sine, cosine, or tangent, based on what sides are available to us. So looking at that 3 and that 5, are we going to use sine, cosine, or tangent here? Okay, that is sine. According to that A, that angle A, I've got the opposite side and the hypotenuse. So that is sine. So what we can say, we know for sure that the sine of A is equal to 3/5. Okay, the sine of angle A is equal to 3/5. That's what we've done before. What we're going to do today is solve for that A. And to solve for that A, just like you always do the opposite of what you have multiplication, you divide to get rid of it. To get rid of a sine, we do inverse sine. So really what's going to happen is this is going to become, all right, angle A is equal to the inverse sine of 3/5. Sort of like square and a square root, right? They undo each other. So this is really the main takeaway of today, is being able to go back and forth between these two ideas. Where you're solving for the angle, we have this inverse sine of the ratio is going to give you that angle. Why don't you go ahead, type that into the calculator. Inverse sine, so second sine, 3 divided by 5 equals. And let's round to the nearest 10th today. What's our angle A going to be here? Al? About 36.9. So angle A, technically they're going to say measure of angle A, but angle A is about 36.9. Any questions on that? Using that inverse there. Okay. What is this side length here? It's got to be a 4, right? It's a 3, 4, 5 triangle. If you know 2 out of the 3, we can fill in that third one. Okay. I want you to tell the person next to you, what other 2 inverses could we do that will get us that same exact angle? What other inverses could we use to solve for angle A? Talk to me about it.
Oh, yeah. I could just look at Oh, I. So if you pull that.
Okay, here we go. So what else could I do here? What other inverse could I use to be able to solve this? Jack?
Inverse of the tangent.
Okay, so inverse tangent of what? What fraction?
3/5. No, 3/4.
3/4, right? Because,
Opposite.
yep, opposite and adjacent. So if we type in inverse tangent of 3/4, that should give us that 36.9. All right, what else? Al?
Inverse cosine of 4/5.
Inverse cosine of 4/5, because now according to A, that's the adjacent and the hypotenuse. So inverse cosine 4/5, again, should give us that 36.9. There are different ways of getting there depending on what side you have. So we got to point that out because they might give you the 3 and the 5, they might give you the 4 and the 5. They might give you the 3 and the 4. You got to be able to solve for that angle no matter which two sides they give you. All right. Questions on our inverse sine, cosine, tangent? All right. Let's take a look at what our problems will look like today.
So far, we know how to take two sides with the third side, and then with this, we can also find the angles.
You got it. You can probably guess what's coming, but we'll get there.
And then-
So some of what you're gonna see is just this, right? And this is just understanding the relationship between regular tangent and inverse tangent, right? So raise your hand, tell me, what would you type in to your calculator for letter A? What would you put into the calculator for that? Al? Yeah, inverse tangent 0.75, and that's gonna give us that angle. The thing that we just gotta be careful of, okay, is a lot of times people will try to do this, but they'll forget to do the inverse. Like if we're looking for angle A, I've had a lot of people in the past that will do, instead of inverse tangent, they'll just do tangent of 3/4. Well, that's finding the tangent of a 0.75 degree angle, right? That's not finding the angle that we want. You have to use the inverse if you're looking for an angle, okay? That's the big takeaway there. You gotta have the inverse if you're looking for an angle. All right, so we'd be able to do those, no problem, we're just typing those in. Okay, questions on that? All right. So the big thing that we can do now is what's called solve a right triangle. Okay, solving a right triangle. They put this as a core concept because it's important. You don't necessarily need to copy that down, but I would read through it just so we know what they're saying. They're asking us to solve a right triangle. They want us to give all the information that's missing. All the sides that are missing, all the angles that are missing. We want all of it. Okay, and they're going to give us two pieces of information other than it's a right triangle. It's got to be a right triangle. But then they're going to give us two pieces of information. They want the rest. So in this case, right, in this triangle here, we're looking for side C. Notice that the side is represented by a lowercase, whereas the angles are represented by capital letters. Okay, that's every single time. So we're looking for side C. We're also looking for angle B, angle A. I want you to go ahead and use everything that we know how to do from this chapter and find those three things. If you need to, talk to somebody about it. I'm sure what you're doing. We're running everything to the nearest 10. I unknowingly gave you a hint on one thing that you could do. Cover that up there. No, you are. Okay, talk to somebody about it. See what they're doing. See if you're doing the same thing here.
How I feel.
Oh my gosh.
Oh, yeah, you're right.
Yeah.
All right, guys, here we go. Here we go. Raise your hand, tell me, what did you do first? Because we could really solve for any of these first. What did you decide to do first, Bryce? Okay, what angle is that giving me?
33.7.
Is that A or B?
B.
33.7. Okay, so he did inverse tangent, 2/3, perfect. That gives you angle B is 33.7. Okay, what else can we do here, Jack?
I found angle A.
Okay, how'd you do it?
Inverse tangent 0.2.
Okay.
I got 56.3.
And once you know one of them, you can do the other, just
Yeah.
90 minus, right? We can do that. I'm okay with that, as long as you're confident you got this right.
I did it the opposite way.
Yep, that's fine, right? But if you're not confident that you got one of them right, then don't use that one to use something else, okay? Vivian?
I just have to base square plus b square equals b square, which is square root of 13.
Square root of 13, and then we're gonna round that to the nearest 10.
3.6.
3.6. Yeah, we're gonna round everything today. They say round to the nearest 10. So about 3.6, okay? Yeah.
Okay, I'm very confused with my guy here, but
Yep.
can guys stop laughing at me? That's funny. Did you take cosine of like C and then do the or I don't know.
So I think I know what you're saying. I think you're saying, all right, if I know this, can't I do cosine of this is equal to 3/c or something like that,
Yeah.
right? We could, I wanna pause you on that because first of all, we rounded that. And anytime we round something, we don't want to use that to solve something else. And secondly, what if we got that wrong,
Okay.
right?
Yeah.
So technically, yes, we can, and it should get you the same thing, but it's not as exact as if we use the numbers they gave.
Alright.
And that, yeah, and that was gonna be my next point, right, is we can solve these other ways. And specifically, you know, I could, if I know that's 3.6, I could do now sine, inverse sine of 2/3.6 to get this angle. And it'll still get you 33.7, but every once in a while, if you do that, it's gonna be off by 0.1. Because we're using a rounded number. And the more rounded numbers we use, the further away from our actual answer we're gonna get. So whenever possible, then we always want to use the numbers that are provided rather than the numbers we came up with. Either because of rounding or again, because what if we got it wrong? Okay, not that you guys should expect to get anything wrong, but just a what if. I don't want to turn one wrong thing into 3 wrong things on the test. Okay. All right, questions on that? Okay. Same idea, different setup, different information provided this time. Okay, so we're solving for all the missing things. So we're solving for angle G, side G, and side H, those 3 things. Yeah, rounding everything to the nearest 10. Okay, talk about it with somebody, see what they did.
I did that. Makes me comfortable. If we all agree on something. And I think
All right, hey, here we go. Here we go.
Yeah, I don't know, it's kind of.
Hey, raise your hand. What's the easiest one to do here? Basic
Angle G,
angle G, what is it?
65.
Yeah, that's just 90 minus 25, right? Nothing special, just triangle sum pyramid. Okay, now, how do we get something else? Here, how are we gonna do something else? Hannah?
I can take cosine G, so well, I did like, and then I did that, and then I did 90. No, that's not the word. G. Hold on. It's all over. the place. And then I did H, and then divided by 13.
Okay. If I'm gonna use H in 13, that's gonna be sine,
Oh yeah, that's good.
right? Because that's opposite hypotenuse. So H over 13, so 13 sine 25 is gonna give us H. What was H, Hannah?
It was 5.5.
About 5.5, okay? So now, instead of doing Pythagorean theorem, because again, we rounded and we got this answer, we don't trust it yet. We have to set something else up. Okay, what are we gonna set up here? Al?
Cosine 25.
There you go. So that would be 13 cosine 25. Al, what do we get there?
About 11.8.
About 11.8. Good deal.
I think.
Okay. Excellent. So that should be everything that we need for that. Okay. We'll talk when we get back.